Digital CxO, and I'm excited to be here today with Arnauld Lamorlette, and he is the CTO of AIVerse. He has a big background in computer graphics. He used to work for DreamWorks, and I'm happy to have him on the show today. How are you?
I'm good. Happy New Year.
Happy New Year to you as well. So can you tell me a little bit about AIVerse and a little bit about your background?
Okay, sure. So quickly, AIVerse is basically a company that generates synthetic images to train neural networks for deep learning. So we generate data set, but the difference is we generate them procedurally, entirely automatically, with computer graphics, basically. I came to AI because of my background in creating synthetic 3D pictures. So I've been doing that for, I don't want to say how long, because it's pretty, I started in 85. So you can see. So basically what happens for when I was in the industry, we did music videos, we did shorts, we did a lot of commercials and feature films and special effects, a lot of special effects too. So basically, for years, I've been creating images for public. So the main difference here now is there are two differences. The first thing is it's not a public anymore. It's a neural network. Okay. So my work is basically the watchers are machines. The difference is the goal is not to sell something or storytelling or entertainment. It's really for the progress of AI.
And we're hearing a lot about AI these days.
Yeah, it's very trendy, but it's a continuing story of using computers to help us in doing our work or doing new things, better things, faster things.
So you were talking to me earlier about how you're using these images to advance and train AI. Can you explain a little bit about how you're using these images and how it's advancing AI technology?
Okay, so here we're speaking about images. Deep learning with images is usually, the concept is quite simple, is you take images, you send the images to countries where labor is cheap, and you have people labeling the images either with squares around what we are interested in, or with vectors. So basically, let's say you want to recognize a dog, you're going to send thousands and thousands of images of dogs, and people are going to make a box around the dog or draw lines around the dog and say, this is a dog. And so it's called labeling. The combination of the image with a dog and the label is called a data set. If you do that with thousands of images, then you expose that to a different deep learning architecture, and they learn to recognize basically a dog. So after you show new images, the neural network has never seen, and it says, oh, this is a dog, this is not a dog. The thing is, it's a very long process. You need to have plenty of images of dogs, and there are a lot of mistakes. Let's say the dog is there is a cat in front of a dog, and you see half of a dog on one side and half of a dog on the other side. So is it two dogs, one dog? How is it? So depending on because it's a human who is labeling today, there are going to be some people will take the whole dog, and some people will take half a dog and half a dog. So introducing bias, you need to have a great diversity of dogs and a great diversity of lighting of a dog. Is it backlit? Is it frontlit? Is it in a room? Is it outside? All these different scenario. And because you are limited to a number of images, you basically, without wanting it, you have a bias. You're going to have more Chihuahuas or more whatever kind of dog you prefer. And I apologize for cat lovers, My example is not with cats, but it will be the same story with cats. So this is a process which is quite long. And the thing is, up to now, if you want to basically train for a lot of diverse category or classes, as we call them, let's say cars and humans and I don't know, books, computers, lamps, laptops, then you will need a lot of images with a lot of diversity. And that's where the GAFAM, let's call them this way, they have a huge advance on everybody because they have a huge database of images. Okay. So basically up to now, and universities have access to this database or this data set, let's call them. And the thing is, because it's long and it costs money, and you need to have the correct images, it limits it's a bottleneck for a lot of companies and for a lot of people who want to access this technology. And let's say you are a small company and you have a product that you want to recognize in a room. You could take pictures of your product in a room, but then you will have to label it and it will lack diversity and you won't be able to put, I don't know, a lot of people around it or with, I don't know, with Chinese people, African people, South American people. And this will be basically difficult for you to achieve that. And anytime you take a picture, I'll give you a very simple example. Let's say the person taking the pictures is, let's say he's 5'11". Okay, 5'10". So most of the picture will have the height, this height for picture, but it's biased because you would want pictures taken underneath and higher, and it will take with the same camera and the lighting. It's very difficult to change lighting unless you are a studio, and so very long process and bias whatever you do. Okay, so that's where AIVerse is trying to break this bottleneck for small companies. What we do is basically we have a site on it's not public yet, but very soon on your screen. So basically you choose the kind of scenario you want. Are you in a room? Are you in a kitchen? At this point, you concentrate on a home interior, but we're going to expand to exteriors and shops and things like that. And you can basically decide, oh, you know what? I want like 20 lighting scenario and I want 10,000 images with, I don't know. And I want images where I see my product for a 45-degree angle. And then I turn every 5 degrees and I want it taken from a picture from a small person, a medium person, a very tall person. All these things that would be very difficult to create and to do and to label on top of that. Because as I said, the labeling at this point is a human process. But by doing it with a computer, then we can, in a matter of hours, create 10,000, 30,000, 100,000 images that have perfect labeling. So to take the example of a dog, we know it's the same dog because it's inside the computer and we can label perfectly. And we can control how much of the image is covered. The occlusion, what we call the occlusion. We know exactly how it's oriented. So a lot of information that would be extremely difficult to get precisely from real images is basically labeled automatically. On top of that, we have more information. We have exact depth, exact orientation. We can vary the material. Let's say you are interested in chairs, and you want to see the same chair with like 20 different materials. That would be nearly impossible to do in real life. Okay. And then you can decide of the angle you get it. And then on top of that, because basically the world is in the computer, normally we have classes like dog, but we could say this is this kind of dog and it's a female and it's age 2. You see, we can refine what we call the superclass, class, subclass instances much better, and we can have much variety. And when we train, because the thing is, if you train a neural network and you give too much of one type, you basically bias your neural network towards what you provided here, because every single pixel of the image we provide to our customers, you can basically decide and exactly distribute statistically exactly things the way you want. So basically controlling possible bias. Basically that's what we do. So the great thing with that is not only we provide very, very accurate data set, but it's accessible to small companies and with no effort at all. You don't need to be a neural network specialist, a machine learning engineer. I mean, of course, if you buy data sets from us, it would be better if you knew what you were doing. But the thing is, the way we've done the thing, we hope it's going to be, no friction experience, where it's basically, it's like a game. You build your environment, your universe, and you say, you know what? I want 10,000 images of that. And then you get the result, you get the statistical distribution, you can get the resolution, all the variation you ask for. And let's say after a while you realize, because usually what people do is they train with a data set and they validate the training. So basically they interrogate the pupil being the neural network, to see they learned their lesson properly. You present them with a new exercise. So basically what you're going to do is you're going to show images of new dogs. Okay. And sometimes it will fail, because this type of dog or this kind of scenario is different. Okay. And then it's called an edge case. And then what you can do is you can come back, you have the exact distribution. You say, you know what? I just had this edge case. And in a matter of days, you can have things that will take, 6 months, 1 year to get. So I think in a way, it's a paradigm shift to offer this kind of product. And I hope will be part of us, a new paradigm shift.
So it's a great partnership between human and machine to speed up the process, but I'm hearing that it's still pretty long and tedious and a lot of trial and error. So how do you test the AI to make sure that you get it right?
The thing is, we can only compare, to measure performances, we can only compare to what I will call the regular live action pictures. So basically, we compared our performances with a database like Coco, which is a common classes. I think it's from Microsoft. I don't want to say something stupid. You have to double check that. And we compared the performances. So most of the time, we beat a live action reference, a live action database, data set. Hundreds and thousands of hours to make and things like that. So we concentrated, let's say, we did that on just to test on plants and couches and beds. And basically we beat the real live action images every single time. Okay. And the nice thing is we can improve and redo the thing like in a matter of hours. That's the thing, is if it's not good enough, we insert new examples, we insert new stuff. So we increase it. It's a push of button, goes on the cloud, boom, you get your images. And all you have to do is to add some. At this point, we can only compare. The problem is we cannot compare with something that has never been done. We can only say, you know what, it works. It gives pretty good results. We did some tests on damage bags in airports, things like that, and it works really, really well. We still have to improve. There's so many things to do. The thing is, we are creating the biggest thing we have is totally procedural. So basically, a lot of people are doing synthetic data set today, but most of the time they take a limited environment which have been already prepared. So they buy 400 houses and they put their camera and that's it. So they're limited to what they have. But our approach is very different because it's all procedural. You have nothing, and we have rules to create distribution in a house, interaction with humans, and all that is totally procedural. So basically you click your button and it's based on rules which are validated, and then we can modify and add and tweak. We can add as many scenarios as we want. So I think that's the two big difference with AIVerse. I mean, synthetic data set, but a lot of people are going towards that. But I think our main advantage is we start from scratch. It's really we create bricks and we build things from the bricks. While most of the people at this point, they just buy environments which are already set and they already have a good result. But the thing is, there's no limit to what we do. It's like, I don't know, what's the game where you build a universe with cubes? What's the name again? What?
Minecraft?
Yes. So basically think of it as Minecraft, where you can build any universe we want. And that's the point. And we are putting bricks, and people, they have, higher level commands, which are interactive actually. And they can build new environments and train on this new environment and images.
So you mentioned the fact that a lot of businesses are moving more towards this technology. So as they move more toward this AI technology and rely on it, do you think there's a big job gap and people looking into this field, there's a lot of openings and they should focus on training more in this area?
It's difficult because I'm really on the, I would say, world creations side at this point. Surprisingly, I'm more a universe creator than it happens that the universe I create is viewed by a neural network. But I think this side, like the film industry, has a huge need of universe creation. I mean, recreation. Okay. I won't speak about the machine learning industry itself because, of course, there's a lot of needs. But this new, how to create synthetic worlds automatically or with, I would say, supervision, put it this way. I think that there's going to be a shift from the people from the game, film industry, FX industry toward artificial intelligence. I already have, all colleagues that are involved into that, either for humans or environments. And I think there are going to be a lot of opportunities. But it's more going from an industry to the other, like I did.
Yes. Yeah, there's a lot of shifts going on from people bouncing from one industry to the other. So I know there was a survey recently from Gartner. 60% of the data used for developing AI and analytics, it would be synthetically generated. Knowing that, what would you say moving forward? What are the uses going to be for this synthetically generated data? Okay,
so we have to separate two things. When we speak about synthetic data, it's not necessarily images. Because a lot of training is not about images. Like ChatGPT is not analyzing images. It's analyzing text. You see what I mean? So ChatGPT could generate data that will help their competition. Because as soon as they generate text, this text comes into what can be analyzed and used as a data set. So I'm surprised. 60% seems low actually for me. The only reason people are not using synthetic data more is because it's complicated to do. But I see no reason to use actual data if you can reproduce it with no bias in a synthetic way. The burden is on the people who are generating the synthetic data because it has to reflect reality. I think that the transition going to be, at least initially, it will be a mix of both of them. Because when you train, in our case, when we mix live action images with our images, it's actually, the results are in AP terms, so people who are in AI, it's one metric, what is called the AP, and we have up to 30% AP increase, which is huge, huge. If we train with our image, let's say we have a score. We train with live action image, we have a score, which is a little bit less, sometimes a little bit more, but we're better because all we have to do is to add images. But if we mix both of them, then it's the result. So I think initially people will mix synthetic data with real data, especially to cover edge cases or cases which are difficult to get or obtain, which makes sense. You see what I mean? Let's say you want to recognize a person from the top or dog from the top. How many pictures of dogs do you have which are exactly from the top? Let's say, I'm saying random things, but let's say you have a very accurate satellite and you want to recognize the dog from the top. So obviously your satellite is in the air and the dog is seen from the top. Okay? So actually you don't have much information about that. I mean, it will be very difficult to get pictures of dogs. So what you're going to do is you're going to mix real pictures with synthetic ones. You mix them together to get a complete training. I see that happening for a while. And then the shift going to happen, progressively. And at the end of the day, say, why do we mix real images, or why do we mix real data? I think that's it's going to be progressive. Another thing I want to say, and I want to insist on that, is whatever you do, you always introduce bias with real live action images. The two reasons you introduce bias, I want to summarize what I said before because it's quite important. The two main biases when using real data is the people who are labeling them. Depending on the culture, the perception of what is seen can be different. I gave the example of a dog. You see part of a dog and other part. Some people will make two. But I give you another example is a seat. What we call a chair or seat. The chair can be interpreted differently depending on the country. Some people won't say a stool is a chair or ottoman is a chair. Yeah, some people will say, no, it's not a chair. Some other people will say, yes, it's a chair. And I've seen actually real live action images where half of the ottoman were labeled as chair and the other half were not labeled. So there's already a bias because it is not a clear definition when you label things. That's the first thing. The first error comes from the labeling because it's a human intervention. And the guys, they do thousands of images per day. So they're going to be tired and they're going to cut into the object. And sometimes they will miss, let's say an example of stack of 20 chairs. The guy will going to take the 20 chairs and go say, okay, chair. Why another guy will make, 17, another guy is going to make 16. You see what I mean? Mm-hmm. And when a chair is behind a table, sometimes you only see the feet of a chair. The legs of the feet, I don't know, you call them legs. and then you are not sure what is on top of the table. Is it still the same chair? It's not. We don't know. Here we know. So the first bias is human. The second bias is the choice or the images you have chosen. Or you have, because you are limited in your number. And that's the second biggest bias is you have a limited set of images. And I won't even speak about bias about race and ethnicity where it becomes tricky even to speak about it. But darker skin are usually more difficult to identify or more precisely than fair skin for a lot of lighting reasons. But this is another bias you could have. Another bias is the But here I'm not speaking about images, is it reproduces, but that's, it's common knowledge. It reproduces the existing bias. Let's say when you speak about automatic sentencing with AI, based on the environment and the parameters. So it's jurisprudence. It's going to take the result of existing sentencing and it's going to apply the same rule. But guess what? Previous sentencing had a lot of biases. So that's the thing, is you reproduce. The problem with AI is not the AI itself, is the training. If you train your neural network with bias, it will reproduce the same bias. Right. So it can be morally wrong, good. I'm not speaking about that at this point. I'd say it's not unbiased, whatever you do. Creating synthetic data, you can still create bias on purpose. That's the difference. Yeah. Usually, if you do a correct job, it should be unbiased. I hope.
So there are a lot of challenges to this process, and the trick is not trying to speed it up, taking your time and not jumping over, making sure to cover all angles, and just trying to train the AI in the best way possible and test the outcome.
Yeah. That's what we're trying to do. And we'll try not to, when we generate things, we try to have as extensive as possible.
Right. Well, I want to thank you for coming on the show today. You have shared so much information for our listeners today. It was very informative, and I appreciate your insight.
I appreciate your call, Amanda, and see you next time.
Thank you.
Take care.